With the exponential growth of virtual production in the XR market, the focus is on the LED volume, as it's not only the focal point, but the most expensive part of the build. Many questions come up in regards to what truly differentiates one LED manufacturer's panel from the others. So we're going to talk about some of this technology and where the market's going as well. So before we jump in, I want our panelists to introduce themselves. Paul, you want to start?
Sure. Hello, my name is Paul Johnston. I'm the Vice President of Technical Operations for Unilumin USA. And my background is over 20 years of direct view LED, as well as all other type of display technologies in my career. So.
Eddie, why don't you go?
Hello. So my name is Nadine Nader Shahi. I'm a chief scientist with Unilumin. Prior to that, chief scientist with Layer, and prior to that, CTO of a company that was also in the LED display business. Again, I also go back about 15 years in this industry. Prior to that, I was in the semiconductor business.
All right, I'll give this another shot here. So Nick Fazio, the director and CEO of Unilumin USA. My background, I come from the system integration world, about 16 years experience doing high-end integration. We started off with a lot of projection blended systems and moved over to an LED technology. And then I transitioned over to the manufacturing world and been there for about 10 years, dealing with a lot of the Asia-based suppliers and creating a North American support structure in the US in order to support those products and basically offer a best-in-class solution to the industry.
That's great. All right, so let's jump in. I've got a lot of good questions here. So first question, Nettie, I'm going to start with you, actually, chief scientist. So I feel like you would be the right person for this question. Lots of specs out there, flip chip, common cathode, COB. Can you please help us understand what each of these means and what are the advantages of each?
Okay, so our industry started with the SMD. And of course, we moved from that to IMDs, and from there to chip-on boards. But there are early versions of the chip-on boards, which was lateral COBs, which was followed by the flip chip COB. So flip chip, COB, IMD, as well as SMD, they're all packaging options. They don't necessarily talk about the technology that is embedded. It's just how the LEDs are packaged. Recently, you might have heard the micro-in packages, which are still different, and there's many different versions of the MIPs. So the advantages of the the COB versus SMD was rather obvious. SMDs package LED dyes, and there's the housing that house them are a cavity, which the package itself is a molded plastic, but the cavity actually directs the light. The idea was that the SMD machines would actually use the SMD to build the PCBs very easily. With the COBs, we actually moved away from SMDs. The advantages were that the package was eliminated. We could actually get smaller in terms of pitch. But also there are advantages in terms of how the light was radiated from the COB. There were a lot of disadvantages with that, and that mainly is in the form of uniformity, which was caused by how the dies were mounted on the PCB and the unevenness of the soldering and things like that. Recently, we've moved into MIPs, and MIP stands for micro-in package, and there are lots of different variations of that. The first variations is micro packages that are mounted on PCBs that are inside the package, and these packages are not very different than the SMDs. But that's not going to last long. Soon we're going to have MIPs that are embedded with the active backplanes. In other words, the substrate where the die sits on is actually active CMOS device, which has its own drivers and so forth. So there's a lot of exciting stuff coming up. And the advantages are obvious. The active matrix allows you to reach higher brightness, much higher brightness, higher refresh rate, packages would be smaller, reliability would be increased, and so forth.
Nick, Paul, anything you guys would add to that?
Quite a bit. However, there are some advantages. Some, well, regards to say,
Yeah, you want to use Nick's? Maybe try that one.
I'll trade. Much better. There are some application differences that sometimes will also lead into the right package that may fit that application. IMD having larger pads, for instance, having like 4-in-1 packages also offer a lot more reliability in certain environments, but can also be a hindrance in other types of applications as well. So it's not one size fits all for everything, right? There's different technologies that are mounting up to costs to different applications environments, because you have LED from outdoor LED, with sunlight hitting rain, sleet, snow on it, all the way into indoor. You've got narrow pixel pitch, all the way down to what you'll see here is our 0.4, right? All the way up to you could have 48 mil, through hole technology. So it's definitely exciting, but it's not that one will replace everything. It's just a progression and making sure that we can meet all of those markets' needs.
Okay, good. All right, so my next question is actually a two-parter. And Paul, I'm going to start with you on this one. So our talk is, let's talk nits and bits. So let's talk nits. When it comes to nits, we know it's related to brightness, but what does a nit actually represent? And then second part, virtual production are asking for brighter, upwards of 1,500 nits or more. Why is that?
Yeah, so a nit is based on an intensity of luminance over a certain period of area, or a meter of area, right? A specific amount of light energy and intensity within that surface area, right? Also known as light candela, right? Which is all based on the candle, for instance, right? And how much light it emits in a certain given space. That's all taken for direct view display technologies like LED, right? So now that gives us basically a variable or a benchmark or a target, that line that we can actually measure things from, right? And then on that, it allows us to define what types of products and what type of energy is needed for those spaces. For instance, for outdoor, you need minimum of 4,500 nits up to, say, 10,000 nits in order to compete with the sun, right? Where when we get into indoor environments, you're looking at anywhere between up to about 1,000 or maybe even 2,000 nits. As we move into virtual production, the sweet spot's been 600 nits, right? Is really what's needed, because you don't need too much light because you'll saturate the imagers, as well as where technology has been currently. But what we are finding is that we're needing more brightness, right, than that 600 nit target. In most cases, currently, you're going to see brightness between 200 and 500 nits is probably that target brightness for the current imagers of today. But as the imagers are getting faster and we're getting below 2 milliseconds, right, we need more brightness in order to capture enough light on that imager to be seen. And so that's why we're migrating into 1,200 nits, 1,500 nits, and I'm sure as technology progresses, we'll continue to see that move up into the even 10,000 nits range.
Nick, Nettie, anything to add? We'll just pass the microphone.
So what Paul was referring to was the capture rate of the cameras. They're getting closer to 2 milliseconds and below. So if you actually use that capture range for a brightness that is 600, you see nothing but dark, basically. So the intention is to actually produce a lot of light, because the CCDs have to actually receive all of that light in less than 2 milliseconds. That's why the requirements for the brightness is getting higher and higher, and 1,500 is not going to be the end of the road. It's just a stopgap.
So next question, this one, Nick, I'm going to start with you. When you look ahead, so when you look at Unilumen's product roadmap, specifically for virtual production and XR, what are you most excited about? Talk a little bit about what that roadmap looks like, and are there any special projects maybe that you guys are currently working on?
Yeah, there's always some special projects that we're working on that are unfortunately under NDA, but it's kind of what drives us as a company is to find and partner with the right entity out there to understand what their need is, and then also to either enhance our existing product line or develop new products that could service that need. We're fortunate enough to have a great ecosystem of partners that are available to us that allow us to get feedback on how they're using the system, the information that's important to them, the features that are important to them, and that helps us kind of focus our efforts on where we go with our product lines. I think what's most exciting to us is really the evolution of the products and the technology, as Nettie was explaining, going into kind of active matrix drivers and the smaller pixel pitches, higher scan rates, higher bit depths for the product. Color space and color in general, color science is something that's hugely important in the virtual production space. And I'm not sure that's something that we probably talk about enough. You probably spend the whole day just talking about color accuracy to ensure that the display that's being used in a virtual production application looks like a real environment on camera as opposed to a display. Unfortunately, we see a ton of virtual production studios that have invested in an entire system, and then they don't have the right team or the right resources to operate it. And I think that's one of the things that Unilumin does best is bring together that whole ecosystem and a group of partners to ensure that we can deliver not just the LED product, but an overall solution.
So you touched on scan rate. My next question delves further into that. Paul, I'm gonna prompt you with this question. So there's been lots of discussion that's centered around scan rate recently, and we know the lower the better. Can you please describe what that is and how low a number you may actually need and why?
Sure. Currently, there's a multitude of scan rates that are needed, and like I talked about a little bit earlier, there's a lot of applications in which LED exists, right? So, and there's different price points as well that are required for those spaces. So, you can have anything from 30 to 1 down to 8 to 1, for instance. And basically what that translates to is how many pixels are being driven off a given IC, right? And so obviously a lower number means that IC is having to work less hard to send as much information to as many pixels. So you're going to have better color steering, better color accuracy, especially in the grayscales, low light levels, and most importantly, you're going to avoid things like banding and stuff that can occur. So that's why you really want to have a lower number. Currently, we have found over the last few years that the 16 to 1 has really been kind of the target point of minimal requirement for the space. But as we continue to drive forward, we're seeing a lot of 8 to 1, and we'll probably continue further. The one challenge is that as we go into tighter pixel pitches, like sub 2 mil, we don't have a lot of area to pack all those ICs to drive it. So that is somewhat of a limiting factor. So there's also a lot of evolution that's to come from smaller packaging, right, or stacking, for instance, that can be done in order to achieve higher pixel pitches like we continue to drive towards, while still being able to maintain that 8 to 1 or even below.
Scan basically refers to a method in which we access the LEDs. The LED drivers, they're expensive. They have to be leveraged across the largest number of LEDs that are on the PCB. The way we actually access these in a configuration which is called passive matrix, which basically means we actually matrix the connections to the LEDs. The less the number of the scans, the more current you actually have to deliver to each LEDs. But more importantly, you can actually increase the refresh rate for a given fixed performance of the LED driver, mainly the LED driver's clock rate. So to live with the scan means to live with the passive matrix. To avoid all of that, you actually go to active matrix, where there is a dedicated driver per pixel or per LED, where you don't have to deal with the issues relating to the scan that Paul just brought up. There are lots and lots of network-related issues that are.
Great. And if you've got questions, keep those in mind, jot them down. We should have a few minutes at the end for questions, so think about questions for these guys. My next question, Nettie, I'm going to stay with you. So with bit rate, we know a higher number is better. Where's the industry currently at, and what's the upside to more bit depth in the future, and how can higher bit depth enhance a production?
Okay, so the bit depth refers to the fidelity by which we actually translate the intentions of the content to what is rendered on the screen. We have, when reference to 16-bit bit depth, for example, means you have 64,000 gray, different levels of gray in order to represent what the input is to the display. So unfortunately, and especially in relationship to passive matrix configurations, the LED drivers do what's called the PWM, or pulse width modulation, and in order to translate the input content to what is rendered on the screen, they have to make compromises. So in today's designs, you see a lot of references to 16-bit processing, which has nothing to do with the way the actual content is rendered on the screen. What you see is more common in how the content is rendered is closer to 8-bit or 9-bit or even 10-bit effective. So the reasons for these compromises are very elaborate and maybe beyond the realms of this conversation. But yes, so today a majority of the displays that you see can render effective 8, 9, or 10-bit, no more than that. 16-bit processing refers to how the pre-processing of these data vectors are done in the controller before they're actually rendered on the screen. So going further, you can actually achieve higher bit depth, but you have to reorganize the PCB design, and you have to avoid passive matrix altogether.
Nick, I'm going to go to you next. So most LED volumes are comprised of rental product. How did we get there, and do you see that changing?
Yeah, I think, so when we look at kind of the how virtual production evolved in the market, it started to really take off in about 2020 as more of a mainstream kind of industry. And at that time, as we all know, we're dealing with COVID. And from what we've seen in our experiences, that we had a lot of rental partners that were sitting on a ton of products for the rental industry, for touring, concerts, live events. And they were basically, when that market was non-existent during COVID, they were able to kind of pivot and provide their products that they had in stock to the studios in order to accommodate the virtual production need, which were the filming that happened during COVID. So that's where I think where we saw the rental and staging products get used first for virtual production. What we see today is, for Unilumin, we have basically two tiers of products. Our indoor products, which are for fixed installation, and then also the rental and staging style products. The fixed install products are typically mounted to a wall where you don't have access to behind the cabinets. So if there's any damage or something that happened and you need to service something, you'd walk up to the display, you'd have to go behind to service it. The rental products have a much better mechanical design. You have access to either the front or the rear for serviceability. And when you're set up in a virtual production studio or a live event, you want to be able to do any service very quickly. So I think you'll see more products like our UPad 4, which we're using here, and the UNano, which is very popular for virtual production with our partners. You'll see more and more of those and evolutions of those type products for virtual production. I think as the technology develops and as we learn more from the space and from our partners, you may see more products that are geared specific to that market, where we'll have a virtual production, branded or marketed product specific to the virtual production market.
Great. So each of you have touched on color. Obviously, we can't talk bits without talking color. Paul, I have got a 3-part question for you on color. So what color spaces are currently available in the market? Can you explain the science of which different diodes support specific color spaces? And when do you think we'll see support for BT 2020?
Great question. So first off, we have a pretty expanded portfolio, and that portfolio will all have different types of diodes and ICs that are used that are also tailored for the applications of which they serve. Normally, most of our products are about 110% of the NTC color space. However, we do have a lot of demand and requirements for also Rec 709 or DCI-P3. So we actually have specific diodes that meet those needs. They also have different price points, of course, as well. And you can order the products, and we even stock some of those products with those types of diodes. Now, to touch a little bit on where we're going for Rec 2020, obviously we're not quite there yet, right? We're definitely doing a lot of development, as many others are, but there's a much bigger equation than just developing a diode itself. There's an entire supply chain that needs to be uplifted. There's new processes that need to be taken. And the other big thing is to realize that there's a lot of other display technologies beyond LED that cannot do it either, or they can do a percentage of it, right? As far as I know, I think only RGB laser can achieve it currently, right, in projection. And even that is very, very new and incredibly expensive. So we are working towards it. You can rest assured that as it comes to fruition, we'll definitely have a product out there, if not a few different products that have that. And actually, I wouldn't mind just having Nettie maybe expand a little bit on kind of what that may take.
Sure. The latter part of your question was, what does it take to achieve it, right? So essentially, what you need to do is there's a color space. I'm sure you're familiar with the CIE color space. In order to achieve wider color space, you actually have to have LEDs that their wavelength reaches out to the corners of these color space. And in order to achieve that, you have to have LEDs that actually have a peak of a wavelength that is higher to those corners. As you know, the wavelength production of the LEDs produces wavelengths that are a curve or a bell curve. So this essentially references what we get from the LED vendors. Today, in the toolbox of their production toolbox, they have means to actually tweak the production to achieve higher wavelengths. But very often they actually are lazy and they just defer to binning the LEDs and providing LEDs that are binning at higher wavelengths. So essentially what you do is you start with a tighter specification for the LEDs and you negotiate those tighter specification and to the extent that they can achieve it, then you actually can then achieve a higher or wider color space with those. And what Paul was referring to is that we're always in negotiation with the LED suppliers to actually tweak and modify their production in order to be able to achieve those things.
Community microphone here, you know? I've got one more question, and then we're going to open it up. We have a few minutes for questions from the audience. So I want to talk moire. We know moire can be an issue. Nettie, why don't you talk a little bit about how to plan for moire and how to avoid moire?
So as you know, moire is caused or actually is experienced by a camera lens due to what's called a points of light. So any light reflection from any material, not just LEDs, even your garment, what you're wearing, as long as it has the stripes or grids, patterns that cause a contrast between black and white. That to the camera, it's experienced as point of lights. And what points of lights essentially do is that the light is emitted not in a straight line. It actually is emitted in a sort of a funnel, funnels out in a waves. And to the extent that these waves overlap and intersect with each other, causes a increase in the brightness, and it's then visible by the lens of the camera. Now, please remember that as these light rays are emitted from the points of lights, they actually go through the first layer of these intersects where they're strongest, and then there we get weaker and weaker and weaker because there's multiple points of intersects. So a couple of things that you can actually do, or people do, is the obvious ones are you resort to a higher resolution, because the higher resolution or a higher pitch actually brings about the very first intersect of these rays much closer to the surface of the LED display, which means that it's further away from the lens. So the lens has to be very, very close in order to be able to actually find these moires. Now, the other parts of this is the way the actual packages are implemented. So the LEDs that are in a package where the points of lights is directed out or collimated in a light, then that actually causes the first intersects to be further away from the screen, which again means that it's more susceptible to visibility by the cameras or lenses. So the package itself also matters. So higher pitch, the format and the shape of the package itself. And then finally, what other people can do is also essentially implement a diffuser right at the corner, at the surface of the LEDs, preferably at a D distance where it is before or right at the first intersect. So you have to know what the package is, you have to know what the intersect points are, and then you implement a diffuser at that point, and then you eliminate it completely. The first two actually don't eliminate it, you just reduce it. But if you really want to eliminate it, you have to implement a diffuser at the distance before the first level of intersect. Hope that helps.
Anything you guys would add?
Yeah, one thing to add is how it's currently done out there is obviously doing these equations aren't easy for most people, right? So what you're going to do is you're going to get out there and you're going to find what those ring zones are, and then usually you're going to have your talent stay out of that area primarily, right? And so that's kind of how it's been going so far, you know, especially in a lot of live production or in House of Worship in particular, where they do a lot of live action. That's what we'll do is we'll find spaces where, okay, put a rug down. That's where your talent goes, and you're out of those ring zones. And then that way it gives you maximum flexibility. So there are some ways that you can work around it when you don't have any other option.
So we've got enough time for a couple of questions from the audience. If you've got a question, raise your hand. We'll get to you. Start right here in the front.
It sounds like there's a lot of changes going on in terms of the technology rapidly. From a investor perspective, return on investment perspective, as opposed to a technical development perspective, how would you address the issue of the usable lifespan in terms of the panels, right? Do they decay over a period of time to the point where they're less usable? And the concern of a facility putting in a multi-million-dollar system that, 6 months from now their equipment is no longer good enough to meet. In a lot of the technology at the show is proven and will last 5, 10, 15 years. but there's sort of the concern that some of this could be out of date in 6 months because you're one or two steps behind the next generation. How do you address that?
I can take that. So our products currently have a half-life cycle of 100,000 hours. And of course, it's a commercial-driven product, right? So it's designed to run 24/7, not like home television that's designed to operate for 2 or 3 hours a day, right? So at 24 hours a day, 7 days a week, 6.7 years, you're going to achieve half the life cycle, which guarantees that you're going to have at least 50% of what your initial brightness is. These decays are well known because the technology's been around for over 20 years, and so we have a lot of actuals and modeling that also show this, right? Obviously, as new diodes come out, we'll have to see how those steer, but overall, that's where we've been able to plant, and so that's kind of where the industry's been for a very long time, and will continue to be for a while. So when you look at that type of lifespan, and that's also assuming that you're driving that display at full bore all the time, right? Most displays are not running 24/7. And most displays are not running full 255 white, right, which is the maximum drive. So you're going to be running video, things like that. Now you're only at about 35 APL. So in those cases, all of that's going to add up to the longevity. And what we usually find is, in most cases, the product itself is still running far beyond its requirement. And normally you're going to find that you're going to say, hey, we're ready to double our resolution or triple our resolution. But from a telemetry standpoint, until we achieve, until something was to change, like you said, oh, well, we need beyond the NTSC color space, then that's going to require a new product, right? Or Rec 2020 comes out and you're like, we have to have that. That's going to require a new product. But most of the time, you're going to just be looking at maybe smaller advancements in, maybe we're running an 8-bit platform. We're going to move ourselves into 10-bit or 12-bit. What's nice is all of our products are already capable of driving up to 12-bit in its infrastructure. It's usually just adding additional data lines and additional processing. So there is a lot of ability to upgrade your system over time. And most importantly, because it's direct view and it's solid state, most of these products usually, if anything, migrate themselves either into, schools or other types of applications or environments that can't necessarily afford to buy the new product, and they can still stretch it another 5 to 10 years very easily. So I hope that answered your question. Yeah.
Anything you guys would add?
Yeah, I think the one thing to add too is a lot of the volumes when they're initially purchased, there's a use case in mind. And as that use case changes, just like any other technologies, right, you have more and more, sorry, I just lost my train of thought. You have more, sorry, drawing a blank. just lost my train of thought there.
All good.
Go on.
Any other questions?
Hi guys, I'm sorry my English is not so good, but I want to know about you how to handle the bunch of pixels. Like when you're using 10 bits or 12 bits, we have like the bandwidth goes to middle, half range of the port of the Cat5, the capacity of the output goes to the middle. How did you get it?
I think what you're asking is as you move up, what kind of steering, what's necessary in order to do that, right? So right now we're currently, the systems out there are using basically 1G, right? We already have some 2.5G product and we have 5G product as well, right? So that's going to give you a lot more bandwidth. But the reality is you're limited to 1G data lines. So depending on whether you're going 8-bit, 10, or 12-bit is going to determine how much of those resources are used. Usually, if you're going from 8 to 12, you're going to cut those resources by 50% or by 100% basically. So you're basically going to go from having a capacity to 50% is what you're going to be able to do in that same line. That's going to translate to basically having to double your processing and double your data lines, right? As we continue to move forward, in the past, it was either 8 or once you went to 10 or 12, it was still 50%. But now what we're seeing is with the processing technology out there is that as you make a step, it's still going to be that for 12-bit, but when you're in 10-bit, you don't lose 50%, right? It's going to be 25% on top of that, right? So there's a gradient there. And so that's going to really define what you can do. And then obviously if you're doing redundancy, that's going to add additional processing as well. So there's a lot of flexibility. All of our products will handle redundancy. You can do up to 12-bit. It's just going to mean how much more of the front end is necessary. And also, what is your pipeline? If your pipeline is only 10-bit, do you really want to make the investment for 12 now, or do you wait until later, right, to do that? In virtual production, 10-bit's kind of really the base to be at, because you need that that higher bit depth in order to have those proper gradients and color steering. But when you go into retail environments or other or pretty much all other type of signage and do out there, it's all going to be 8-bit is more than enough, right? And we are starting to see more people push towards the 12, but those workflows aren't as predominant yet.
I think we've got time for one more question. Who's it going to be? Any other questions? All right. Well, I saved a bonus question, so I'm gonna take the last question. Paul, I'm gonna ask you this. So when it comes to processing platforms, I understand that Unilumin supports Megapixel, Brompton, and Novastar. What's the difference between all of these, and why should it matter?
There are 3 great companies that we work with, and they all have a different way and approach to dealing with processing of those pixels. They also have different feature sets, and some of those features are actually exclusive to their platform because there's IP involved. And then they also have a different UI experience as well, right? And most importantly, a different price point. So our goal is to make sure that we work with each of those manufacturers for processing to make sure that our products are optimized with each of their platforms. So at the end of the day, your solution is custom tailored to meet your needs and also allow you to work with whatever platform that meets that you're most comfortable with. There are some houses that are Novastar houses, some that are Megapixel, some are Brompton, right? They don't want to change that UI because it's a whole nother level of learning, right? They also don't have extra processors on the shelf, for instance. Do you want to have all this additional capital sitting on the shelf, or do you want to kind of standardize within house? So our goal is to make sure that you can get Unilumin product regardless of which platform you use, and we are also here to help you make those determinations. So if you're not quite sure, part of our sales team, we're going to be involved with letting you know the benefits of each and understand what you're wanting to do, and then most importantly, make sure that you make that right decision.